Alright, hi everyone. Welcome to this video where we'll be completing the last part on writing and balancing a chemical equation. Right, so before we go on to that, let's run through worksheet 4 first. Now in this video, I will only be going through question 1 to 6 of worksheet 4. Right, so for those of you who have completed it, you can take this as a check of your understanding. Right, so that eventually you can submit the worksheet for me to double check. For those of you who have not completed it, you may want to use this to maybe have a guided practice, or you want to pause the video now, try this out yourself before you watch the rest of the video. Okay, so we'll run through the first 6 questions here in the worksheet 4. Then we'll proceed back to the notes to complete practice 1, 2, and 3. And then we'll round it up with some practice questions on worksheet 5. Okay, so let's first start with worksheet 4, question 1. Right, so over here, for this particular balance of equation, do take note that we are trying to make sure that the number matches. So when you look at this first equation here, you realize that there's actually 2 of the oxygen on the right hand side, but there's only 1 of the oxygen on the left hand side. So usually what I do first now is that I will actually put a 2 here. A bit of back and forth might be required, right? So we do have to see how the entire equation works out to be. Now when I put a 2HGO here, I'll realize that I've introduced 2 of the Hg, but on the right hand side there's only 1 of the Hg, and therefore I need to put a 2 over here. And if this entire thing works out well, this will be my balance equation. Right, so that's for example 1. Let's take a look at example 2. 1 Na H2O give you NaOH with H2O. Right, so you look at this entire thing similarly, you realize that the Na is actually kind of balanced on both sides, so we can skip the Na. Then you look at the H, you realize that there's a bit of problem. There's 2 H here, but there's 1 H and then 2 H over here. So we realize that the H is not balanced. Now we look at the O, there's 1 H here, 1 O here, and there's 1 O here. So the O is actually the balance. So what this means is that actually we do have to find a way to match the number of H on both sides. And if you look at it carefully, you realize that 2H, 1H, and 2H, there's actually a difference in terms of the even and odd number. So what we'll do first is actually we'll increase this to 2. Why do we do that? Because this will now increase my H here to 2 of H. My H here will be 2 of H. This will give me an even number of H to work with, which is easier because now I can then change this to a 2. And then my H will actually be balanced up. Instead, if you decided to change the H here to a different number, this will make it more complicated because you'll be working with even and odd number, and it's a lot harder for you to balance the entire thing. Okay, so I just repeat again. I will put a 2 here, and when I do this, my H2O here now to balance it will be a 2. And this time if you look at it carefully, there's 4H, there's 4H, there is 2O, there's 2O. It seems to be pretty well already, but let's not forget that we actually changed something here to the Na, and something must change over here as well. And that's why this first equation will be 2, 2, 2 for the balancing. Let's try out the third example. Now the third example, there's a hint that's given here in the answer key, which is that we should balance the carbon first. This is definitely not an easy question because there's a big number, there's a lot of different elements. But let's try out the carbon first. There's 10 carbon on the left hand side, so let's give it a 10 here on the right hand side. Now let's look at the H. There's 16 on the left hand side, the right side there's only 1 of it, and let's give it a 16 over here. So now the carbon is okay, the H is okay. But this time around when you do this, there's actually 16 of the Cl that introduced. Here there's a Cl2, right? In order to match the number, it's actually an 8 over here. Now why is it an 8 and why is it not a 16? Okay, it's because you must take note that there is a Cl2 over here. Therefore, if you want 16 Cl, 8 will be the number that you go for. And then this should be the balance equation. Alright, let's try out the fourth one now. Fourth one now, there's also another hint, a tip for you, is that actually there's a way to work around this to make it easier because there's so many different formula over here. That's actually to focus on the sulfate. Now this sulfate is actually one big group by itself. Why is it good to focus on this? Because you realize that the group actually stays on the right hand side. Now this helps in a lot of ways because number one, instead of trying to balance each of the symbol like S, F, E, O, and H, now if you look at this, there's a SO4 here. There's actually 3 sets of SO4 here. What this means is that you must have a 3 set here. If not, you can't possibly have 3 sets of SO4 appearing on the right hand side. I hope you are following so far, because this will be a very important tip to help with balancing of the chemical equation. Next, so SO4 is done. Fe here, there's two of it, but here there's only one, so naturally we'll put a 2 here, right? So it seems like the Fe is done, the SO4 is done, but now we're left with the H2O to check whether the balancing is completed yet. In total, if you count it properly, so this one I may have to write it out on the separate side as well. The total number of O they see on this entire diagram on the left hand side, now based on what we are balancing so far, there's actually 6 of the oxygen. Why 6? Because there's 3 here, and then there's a 2 times. Okay, how many H are there? There's 3 here, and then there's a 2 times, there's 6 of the H. But over here, there's also 6 of the H. So there's actually 12 H on the left hand side. Okay, on the right hand side, we realize that there's only one set of the O, and there's 2 sets of the H. Now, how do I match them up? Those of you who are good in mathematics, you realize that actually all I need to do is to put a 6 over here, because this will allow me to balance up the entire left and right side in terms of the number of O and number of H. And then this entire formula will be balanced, this entire equation will be balanced in this manner, right? So it's not that easy for question 4, right? And I believe that for some of the other questions, it's also quite hard, right? So let's take a look at question 5 now, just to run through again. Left hand side, Fe, there's 2 of them. Right hand side, there's only 1. So my first step is I will try to balance it first. Left hand side, the O, there's 3 of them. The right hand side, the H2O, there's 1 of it. So I will try to balance it out by putting a 3 here. So now my Fe is done, my O is done. I look at my H. So right hand side, I have 6 of the H. Left hand side, I only have 2 of the H. I'll put in a 3 here, and this will balance up the entire thing. Okay, then let's go on to question 6. Left hand side, I see a H2O2. Right hand side, I see a H2O and an O2. So the H is actually balanced, not an issue. But the O is a problem, because on the left hand side, I see 2 of them. On the right hand side, I have 1 and 2. So do I change this O2 or do I change this 1? Okay, because on the left hand side is an even number. I know that no matter what number I put here, it will always be even. My best bet is to actually change this to an even number. So I will have to, let's say for example, push this up to a 2. When this thing happens, there's 2 of the O. Here there's 2 of the O, so totally I have 4 of the oxygen. But only over here I have only 2 of the oxygen. So I can actually top it up to a 2 here. Now this time round, I will have 4 of the hydrogen, 4 of the oxygen, 4 of the hydrogen, 2 of the oxygen, with another 2 of the oxygen. So this will actually be the balance equation for number 6. Okay, so I hope this gives you a bit more confidence in terms of what you're doing. If you're getting it right so far, good job. If not, try to pick it up and see what's the issue. Right? Remember, balancing an equation is about hard work, patience, and practice. Eventually, you'll get there. Okay, so now with that, let's go back to the notes whereby we will now construct a chemical equation from scratch. So far, we have been writing in numbers, and the questions are very kind. They gave us the formula. But in the actual question that you'll come across is that you do have to construct your own equation. So let's take a look at practice 1 and practice 2 of the notes. So methane is a chemical that has a formula of CH4, right? Oxygen has a formula of O2, right? Of course, carbon dioxide is our CO2, and water is our H2O. So with this bit of equation, what it helps with is that you can start by writing out how should be the normal formula looking like. Leave some spacing in between because you may have to put in numbers, and balancing takes a while. So once you have this thing out, this is the first step, right? So I'm going to use different color to show you my thinking process. Now I'm going to balance the carbon. Over here, I see 1 carbon. I see 1 carbon over here. So I'm not going to do anything to the carbon. Over here, I see 4 hydrogen here. I see 2 hydrogen here. So my first thinking step is that I will put a 2 here first. Now, whether or not it makes sense, I wouldn't know because I need to balance up the entire thing. But at least I know that now I can account for the number of hydrogen and making sure it's balanced with what I see on the other side. O2. On the left hand side here, I have 2 of the O2. Sorry, I have 1 of the O2, which is 2 oxygen. On the right hand side here, I have 2 oxygen here. but now I also have 2 oxygen here. So total I actually have 4 of the oxygen. And to balance this entire thing up, I need a 2 here. This will give me another 2 of the oxygen. And this will be my balance equation. Okay, so let's try out for practice 2 now. Practice 2 for sodium is Na in the formula. A jar of chlorine gas. Chlorine gas is a group 17 chemical, which is diatomic, so it's Cl2. You actually form a solid of sodium chloride, NaCl. How do I know it's NaCl? Because Na is Na plus, Cl is Cl minus, and together I do a crisscross method, I'll get NaCl. Okay, so this entire equation I can actually express it as Na plus Cl2 giving me NaCl, leaving some space in between to balance. First to check, Na left hand side is 1, right side is 1, is fine. Chlorine left hand side is 2 of it, right hand side there's only 1 of it, which is not okay, so I need to add in a 2 over here. But this time round my Na is not balanced, and then I put it back on the left hand side with my Na. So this is how my balance equation will look like. Now, as you're going through this thing, you might be thinking that, okay, it seems straightforward because the teacher can move very fast. But I do want to highlight one important thing for this whole question is that, how do I even know what's the formula of sodium metal? You need to first make sure that you are clear with your formula of your metals, that they are actually just a symbol. How do I know that chlorine is Cl2? You need to first remember that your group 17 elements are diatomic. How do I know that sodium chloride is NaCl? It's not because I take Na with Cl for the chlorine. It's actually because I must first know that there are charges and ions. So there is some thinking required here that is not that straightforward. I just want to highlight this because at the start it will be challenging to do it, but it's usually because students forgot about all these blue highlighted parts. Foundation not strong will cause issue in chemical equation. So if your foundation is not strong at this point, I will really encourage you to try to recap all your formula, right? All your ions, all the covalent substance, so that you are very clear about what is the formula first. If not, you will have a lot of issue with equation. Right, so let's move on to the last 3 examples here, 3, 4, and 5. Right, so for 3, same thing. With concept that is strong, sodium is Na, H2O is water, and this will form sodium hydroxide. Now, sodium hydroxide, how do I know what's the formula? Sodium as an ionic structure is Na plus. Hydroxide is one of the formula that we must remember is NaOH. So together, this will give me NaOH. Sorry, hydroxide is OH minus. Then this will give me NaOH. Hydrogen gas is one of the diatomic element and it's H2. So with this entire thing, my word equation will be sodium plus water forming with the arrow sodium hydroxide plus hydrogen gas. Okay, and this will be Na plus H2O arrow NaOH plus H2. So why don't you try to balance this yourself? Right. So this is the first one, right? You can pause the video to balance it yourself, or you can continue to let the video run through. We'll run through practice 4 and 5. Likewise, I will require you to balance yourself as well. Okay, so practice 4, aqueous hydrochloric acid is HCl. Magnesium as a metal, the formula is just the metal itself. It forms magnesium chloride. So magnesium chloride is an ionic structure, whereas metal and non-metal. Magnesium is a 2 plus, chloride is a Cl minus. So together the formula is MgCl2. Hydrogen is a diatomic molecule, it's H2. So this entire word equation will be hydrochloric acid plus magnesium forms magnesium chloride plus hydrogen. Okay, why don't you construct the equation yourself? Right, and then for the very last one here on practice 5, sulfuric acid H2SO4 reacts with calcium carbonate. Now what is calcium carbonate? Calcium carbonate is an ionic structure. Calcium is an ion of Ca2 plus. Carbonate we do need to memorize is CO3 2 minus. So together this will give us formula of Let's shift this up. CaCO3. It forms calcium sulfate. Calcium as an ion is Ca2 plus, sulfate is SO42 minus. Here give us a formula of CaSO4, right? Carbon dioxide is CO2, water is H2O. So this entire equation will now be sulfuric acid plus calcium carbonate forming calcium sulfate plus carbon dioxide plus water. Similarly, can you take this equation and try to construct one by yourself, right? So I think this is the best way to learn, so you're very familiar with how the chemical equation should be constructed, right? And once you're done with this one, go and attempt worksheet 5. That should occupy you for quite a bit of time, right? And then you can double check your answer by bringing it to class. We'll run through it together, or you can watch the next video, which will show you a bit of in terms of the kind of question that you see in worksheet 5.